Ragabala sir,
Yes, ma'am.
you
Actually,
can make me the co-host.
yes, ma'am. I have already made you the co-host.
Oh, okay, okay, sir.
Madam, uh, should we
Hello.
start then?
Sir, you're
Yes,
able to
ma'am.
hear me, Rangabala sir? Yes, sir. Let us
Yes, ma'am.
start.
Right.
Students will be joining. Let us please start.
Yes.
Sorry for the delay, sir. Amit sir, we'll just start now, sir.
Okay, madam.
Okay. So good afternoon, one and all. I am Rangavalla Pradhan. I'm an assistant professor in the Department of Computer Science and Engineering at ITER SOA University. I would like to welcome you all to this 42nd webinar in the uh, SOA weekly webinar series. So this SOA weekly webinar series, it's a great opportunity for all of us to learn new research, perspective, new research directions. Every week we listen to different research experts coming from various backgrounds like industry and academics, and to interact with them, to make collaborations with them to future research. So in this regard, we have with us today Dr. Amit Kumar Singh. Welcome, Dr. Singh. Uh, he is
Thank
currently
you, sir.
working as an assistant professor in the Department of Computer Science and Engineering in SRM University, Andhra Pradesh. He has a PhD in Computer Science and Engineering from Indian Institute of Technology, IIT ISM Dhanbad. He has done his MTech in Computer Science from NIT Durgapur and a BTech degree from Jalpaiguri Government Engineering College. Uh, he has also worked in IT industry for some time before coming to the field of this academics and research. So he has a decent blend of experience from industry and academics. He is an emerging researcher working in the area of vehicular delay-tolerant network, intelligent vehicles, and Internet of Things. He has a sound list of publications in reputed journals indexed by SCI, Scopus, Web of Science, and some conference proceedings and book chapters to his name. So, without any further ado, I would like to ask Dr. Singh to take over from now and present his talk on today's webinar topic, which is Vehicular Delay-Tolerant Network, Key Challenges and Future Perspectives. Dr. Singh,
Guru, madam, and all the
you can
organi.
present your screen now, sir.
Yes, I will do it. And due to power cut, I have some foundation, so I will stop sharing my video.
Oh, okay,
Means I
okay,
will share
ma'am.
my
Okay, sir.
presentation.
That
So
is no, not an issue.
is it visual, sir?
Yes, it is coming.
So just give me a minute.
Sure, sir.
So, sir, it means is my screen visible to all?
Yes, it is visible, sir. You can continue.
Sir, thank you. Thank you for confirmation. So, as my topic is vehicular delay tolerant network and the key challenges and the future perspectives in the vehicular delay tolerant network research work. So, Ballab sir has already introduced, given us such a nice introduction of mine. So, I don't need to introduce myself again. So, in this presentation, some outlines are there, like introduction. In the introduction itself, I will introduce the origin of vehicular delay tolerant network and the basics required for the vehicular delay tolerant network, and some issues and research problems uh, which are identified by me and some other researchers. Okay, and after the brief introduction of the vehicular delay tolerant network, uh, I will introduce one of my work and how I have solved the problem, one of the problem in this area. So now I will start without wasting time. So vehicular delay tolerant network started from its origin is delay tolerant network, and delay tolerant network started actually from for a space communication. So this is the definition which is already available in the website of NASA. So anybody can go and read if they are interested in delay tolerant network. This is the link I have shared in the screen. And according to NASA, uh, the delay tolerant network is an approach to computer network architecture that seeks to address the technical issues in heterogeneous networks that may lack continuous network connectivity. Okay, so when our regular networks in the sense means a conventional networks fail to work in the situation when a disconnection occurs. So at that time, delay tolerant network provides support. So by using a delay tolerant network, we can solve the problems. Okay. So how it is different from the in-to-in network, which is our conventional network, is the DTN. How it is different from the in-to-in network. So DTN can work when the disconnection occurs and it can increase the throughput compared to in-to-in network. Okay, so in case of as we can see in the upper picture graph that in case of TCP and UDP. So in case of TCP and UDP, if any link fail, disconnection occur, then the message from source to destination it waits too long, and after some time it get failed. But in terms of delay tolerant network DTN, the increment of progress without in path. Okay, so in DTN, basically what happens in DTN, it adopt it use stop store, carry, and forward paradigm. So by using this stop, carry, and forward paradigm, means after having a disconnection also it can work. Okay, so so this is how a DTN is different from this conventional network we are using in our day-to-day life. So wherever disconnection occur, we can use suppose in some point of time some disconnection occur between source and destination. So for that point, we can use this DTN to get our packets delivered. Okay, so so some application, without knowing the application, we cannot understand the total overview of delay tolerant network. So how it works? So you might have seen that underwater network in underwater and in space communication. It is very difficult. when we are going to imagine it itself, so it is very difficult. We cannot means even imagine that means how the networks are going on, means how the means source is connected to destination, but somehow it is connected, and somehow the NASA and other means other space centers are using the delay tolerant network concept there also. So in the application terms, the, the DTN is useful in underwater networks, in oceanography data collections when we want to collect data. Then we can use the DTN for easy collection of data at that. And in terms of real life scenario, means general life scenario, then a pollution means for pollution monitoring, and in terms of disaster prevention. In one of my work, which I which I'm going to explain. So in that work, this application means I have worked upon this application, disaster prevention. Okay, and another application is a traffic improvement. For traffic improvement, we can use this delay tolerant network in terms of vehicular delay tolerant network. Okay, and for military battlefield, as you know, that means always it is not possible to have a connection all the time. So in that term also, in means in military battlefield also, we can use this uh, delay tolerant network. So some of the successful projects of the DTN, that is a zebra net for tracking zebras in the means in the forest, and means like swim for a well tracking means swim is a famous project for well tracking, and for means as darknet was a successful project for providing internet in the rural areas, because in some rural areas it was not possible to have an internet connection all the time. So with the use of this DTN, this darknet project has provided means internet in the rural areas. And means a Kaifunet is also for providing an internet in the remote areas where internet was not easy to reach to all the people. So at that time, so Kioxnet project was performed to and it was successfully completed at that time. And solar system internet also for internet in space. So these are the famous project. So now, means after discussing the DTN, the base of the backward delay tolerant network, we will means I will discuss what is backward delay tolerant network, and so we all are familiar with a VANET. So in VANET or in a backward network, the in VANET or in backward network, we always use means conventional network. But in terms of a vehicular delay tolerant network, in the vehicular delay tolerant network is also a specific means a specific research area of a vehicular network. But here, some restrictions occur because of the disconnectivity. So so we assume that means always there is not means always there is no availability of connections. So when a disconnection occurs, this vehicular delay tolerant network can uh, can provide a better support as compared to other networks, means other vehicular networks. So what are the issues, and means how it comes? So this highly dynamic topology means in vehicular delay tolerant network, is highly dynamic topology because of the vehicular nodes available in this vehicular delay tolerant network, and the absence of the end-to-end network, as I discussed, that absence of the end-to-end network, because in we are assuming that we are working with the delay tolerant network, and there are some disconnection, and always it means that always there is no connection between source and destination. So means in our network scenario, we are considering a vehicular delay tolerant network, and it will means it will support with or without means infrastructure. Okay, And the next one is data ranges from messages to large video content. So it means in the transfer, the data range can be from a small message, means the size of the message is very small, to a large video content. It means to say that from small files to a large file. And how it happens? It happens means it happens with vehicle to RSU communication, vehicle to Bluetooth communication, vehicle to vehicle communication, and all. So in in vehicular-delay-tolerant network, it is a similar, means it's similar to a vehicular network. So in vehicular network, what are the main contents? The main contents are RSU and OBU. So OBU is the onboard unit, which is present at the vehicle, which is inbuilt with the vehicle, and RSU is the roadside unit, which is deployed means roadside to communicate with vehicle to RSU, or if there is some infrastructure, then we can communicate with from vehicle to infrastructure or some other sources with the help of OBU and RSU. They means actually they work to transfer the data from a vehicle to other sources. Okay, and it works with it works with opportunistic networks environment. Opportunistic network environment means when a vehicle or some other sources will come under the range of the other network, then only it will transfer. Suppose two nodes are there, and if the nodes will come means in the range of each other, then only they will transfer their packets. So this is how means opportunistic network work. Okay, and Internet of Things, because of if we are going to collect the data, means like I will show in my work how means we have used. So means at the time of collection of data, we will use this connective, means for connectivity and for collection of data, we will use some sensors, or for some other uh, means for some other transfers also we use sensors. So at that time, in the architecture of VDTN, Internet of Things is also included. So these are the simulators and experimental softwares available for VDTN. That is means opportunistic network environment, one simulator, and NS3 means many versions of ON, means one simulators are there, but I was using 1.6 at that time. So this is one simulator, and NS3 also. NS3 is based on C++ and Python. So you can use according to your convenience, and you can integrate Sumo with NS3 and means opportunistic network environment also. And sometimes we plot our means a network scenario in Python also. So independent, and after collecting getting the data from means if we want to extract the data from some data source, means some data sets, and we can use a Python also here. Okay, so now the some research problems I have identified, and some other from some other sources also. So there are few only I am introducing. There is the first one is a design and implementation of VDTN model for a real life scenario. So as I told that in VDTN, it is very difficult to establish proper routing or proper topology because of the dynamic nature of these vehicular nodes. So so for designing and implementation of this VDTN model, means in the next design of an efficient relay node selection and strategy for better performance. So means a selection of nodes also at the time of routing is very important. How it is important? If we will select some inefficient node, and it will drop the packet, I will explain in the next slides. it will means if it will means if it is going to drop the packet, then the performance of the means the performance means of the routing means or the means efficiency of the model will decrease. So a selection of an efficient relay nodes is what it will transfer a packet from source to destination. So intermediate nodes, so these intermediate moving nodes are called relay nodes here. Okay, so and the next one, the problem of selfishness and its region in the Vehicular-Delay-Tolerant network. So selfishness actually a main problem in the delay-tolerant network and in Vehicular-Delay-Tolerant network. So there are many papers who have who has provided solutions for the selfishness, but it is still there. Selfishness is what? Suppose from source means if a vehicular delay means if a vehicular nodes means accepts a packet for transferring the packet to another node or to the destination, but means in between, if it will drop the packet due to means insufficient buffer storage or some other problem, it will drop the packet. I don't want to carry and miss it has already stored the packet from the source, but it don't want to carry and forward to the destination. So at that time, what will happen? The regular means that particular node will drop the packet, and after that means finally the performance will decrease. So the next problem is the high speed of the vehicles. So in VDTN or in any other vehicular network has a short contact period between nodes and nodes or between nodes or infrastructure or between nodes or RSU. So this problem to re-examine the QoS means issues in the VDTNs in this context, it will be means a good problem if means a quality of services if you will means if you want to solve this problem. So this is means untouched type of problem here. Okay, and one more problem I want to discuss, that is means low density in Vehicular-Delay-Tolerant network. So if means low density in Vehicular-Delay-Tolerant network is there, then it is very difficult to means to deliver a packet, and and finally the same thing, the performance is decreasing. So these are the research problems in the VDTN, and after when we will go to solve this problem, so these are the challenges and motivations, because incomplete data transfer. So our first challenge is incomplete data transfer. So as VDTN includes moving vehicles for communication, and incomplete transfer of bundle due to insufficient time and stay in the interface range is one of the main motive. So means incomplete data transfer, because means as I explained that means some nodes don't want to carry forward the packets or bundles. So at that time means incomplete data transfer is there. So this is the main problem. So if so these challenges you will face when you will going to implement any of the problem in this. And droppage of bundle, as we have as I have explained during the research problem, that during communication in VDTN, suppose at any point if vehicle stops communicating due to any problem, due to any other problem also, or due to its selfishness, that it don't want to carry forward the packet because of the memory space or buffer space, anything. So it has to stop the packets, and at that time the TTL expires before destination. So this is the so this droppage of bundles is going to affect the performance and the results. So these are the challenges, and one more challenge, that is a bundle transfer failure. So this is somehow same as that if vehicle don't wants to transfer the packet and fails to transfer the bundle custody without estimating the time and speed. So when a vehicle to vehicle transfer is going on, so at that time, if vehicle, it means if vehicle don't know the speed of the another vehicle, so at that time, means a relative, means if they don't know, and means if they are not calculating the relative speed, um, means according to the another vehicle, next vehicle, it means it is going to transfer the packet. Okay, so at that time it will be a bundle transfer failure, because the source vehicle, which is also a moving vehicle, and it is not able to transfer the packet because of without estimate, because without misestimating the time and speed of the another vehicle, it is transferring the packet, it is trying to transfer the packet. So this is the reason a bundle transfer failure can occur. So latency at the final fails to reach destination, and TTL expires before delivery, so latency will increase. Another two challenges are absence of efficient relay selection strategies, as at the time of research problem I discussed it, and delivery and delay. So now, after this a brief introduction of this Vehicular-Delay-Tolerant network and its origin, I'm going to present one of my work that is under revision. I have submitted two revisions transaction, IEEE transaction. Okay. So this problem statement is like a smart transportation system utilizing Vehicular-Delay-Tolerant network for automated medical services. So medical services at the time of pandemic, pandemic and some other disasters. So I have assumed that during COVID situation. So at the time of COVID situation, some other disaster like Amphan in Odisha, like 2 years back, when we will go. So at that time, Amphan and COVID occurred together. So according to that, I have assumed the network scenario, and I have provided a solution. But before that, I want to discuss some related work that is required, because these are the standard work of the delay-tolerant network. That is a first contact protocol, and in this protocol, the source node transfers the packet to the first node within its range and transfer the packet hop by hop to the destination. So in the second one, that is an epidemic protocol, and most of the people are familiar with this epidemic protocol, because at least epidemic word, because in this it broadcasts the packets. This node forwards the packet to every node it encounters. So epidemic is taken from some epidemic diseases, like pandemic. So whoever will come in contact with it, so it going to spread with them also. So it is similar to that. Note those who are contact with the source node, so they will get the packet. And in Prophet protocol, nodes gather information about encounter history of the node, then using transitive properties forward, in forwarding the packets. Okay, and some other works are Bayesian networks, in which they are using the Bayesian networks, and in navigation they are using the Navy-Bayes routing algorithm only. Here I want to introduce this adaptive carry, store, and forward strategy, because here they have calculated. So here they have calculated the estimated a relative speed. So they have considered one of the problem, that is from vehicle for vehicle to vehicle transfer. When vehicle to vehicle transfer is going on, so for a source vehicle which is also in a moving condition, so it is very difficult to transfer a packet to another moving vehicle, vehicular node, which is also in a moving condition. So at that time, So if a source node can means estimate the speed and the means speed means of the means next relay node, then it will be easy to estimate that we means in this time period we can transfer the packet. So the author has done the same here. uh, means here they have changed means they have means provided the solution means in a way that a source node means a source moving vehicle can adapt the speed according to the destination speed, means a moving vehicle speed, so that it can transfer the packet easily according to the adaptive so that's why this is called means adaptive carry, store and forward strategy. Okay, so after that a cooperative store, carry and forward speed, it means in this bi-directional moving vehicles, and it selects two vehicles in both the direction and deploy them as means relay, but it depends upon the inter-ISU cooperation. So it is very difficult in the real life situation to uh, uh, to provide a cooperative scheme, to implement a cooperative scheme. So next one is PVRS, which is a proposed decision-based routing scheme. So now the issues with this standard protocol. What are the issues with this standard protocol? So the issues exist. This means again the same. The large number of replications and the wastage of resources in epidemic and prophet protocols. Okay, so in the epidemic, in terms of epidemic, because it is transferring the packet to each and every node, which is which is going or coming in the contact of the source node. So means it's a wastage of resources, wastage of bundles. We are means it is sending because the duplicate packets are sent to all, many of the means nodes. Okay, so and the second point is the total delay and the queuing delay are very high in case of BN and means NV, that is a uh, Bayesian network and the Navy Bayesian network paper, because these protocols cannot be implemented in case of emergency or post-disaster situation, because if some delay will occur there, then it is very difficult to implement, because we are providing solution at the time of emergency or means we are providing a post-disaster solutions. Okay, so if if delay will occur, then it is very difficult to provide a solution for the disasters or for emergency situation. And another the next issue is the delivery performance is low in all scenarios in epidemic, prophet and first contact router. Okay, and in ACSF and in PVRS protocols are not realistic and feasible, as I as I mentioned, and in the CSCF protocol performance totally and depends upon the cooperation RSU, which is not cost effective and also not feasible in real life scenario. So in this work, the key challenges and the motivations are that means absence of an automated model which can provide medical, means as I mentioned, that I am providing a solution for means a pandemic and means a core disaster occurred simultaneously, like Amphan. So means at the time, so absence of an automated model which can provide medical facilities at the time of pandemic, means like COVID-19. So human to human contact can means infect more people and healthcare personals while testing and sample solutions. So for that, I want to provide the solution so that automated vehicles can take collect the data. Okay, and it can provide means it can send the data to RSU and to the main data center. Okay, and after that, a conventional network failure in that case of disconnection means occurs. So means at the time of connection, conventional network. So at that time, this means by using a Vehicular-Delay-Tolerant network, we can provide a solution. and the conventional network setup is not feasible if some disconnection occurred due to some storm, wind, or some other disaster. Like I mentioned, means I'm considering Amphan like situation. So at that time, it is very difficult to set up means complete network means if it is a conventional network. But we can deploy some RSU and we can provide a temporary solution by using a vehicular-delay-tolerant network at that time. And the last one is delivery and delay. It is very important to deliver the means information and means information to the citizens at the time of disaster and emergency situations without any delay. So we are using this VDTN and for means as a solution here. Okay, so our contribution is like the proposed model provides an automated vehicular network model to detect an infected person during a pandemic and disaster by collecting means after collecting a data from them, and means when it will reach to a main RSU, then there it is going to classify, and after classifying they are providing this they are providing solutions to each and everyone means according to their disease. So the next one is the model provides medical facilities to the people according to the disease after classifying their diseases. Okay, and the next one is the proposed model performs well even on the failure of the conventional network in the considered scenario. So I have implemented this with an one simulator and some Python for some data sets, and after that the proposed VDTN model is compared with the existing routing strategy as to prove. So means as an initial network scenario, I have considered this that means in the initial network scenario, some means I have taken some colonies are there, and this colonies is this colony is divided into some blocks, and some hospitals are available in that colony, but it is not. But we don't want to send means healthcare workers to go each and means every home to collect the data means data in terms of means who is having what type of symptoms means is it related to COVID or some other disease. So at that time we need to provide the medical facility if anyone is in need, because and we are considering that means at this situation. So at this situation, COVID-19 means COVID-19 plus some disasters like Amphan is also occurred. So we are going to provide a solution for each and every means in each and every citizen of this colony. Okay, by setting up some RSU, means that is a local RSU and some means and the main RSU. So the main RSU is the means we have considered a data center where means we are classifying the data of means all the citizens, and after classifying the data, we are sending it means we are sending this data to the concerned hospitals, and from the concerned hospitals, these hospitals will provide ambulance services or whatever services a citizen is required means at that time. Okay, so suppose if the citizens means if citizens are means in need means for a COVID-19 means hospital, if they have the symptoms like a COVID-19 symptoms. So means this ambulance will go and carry this people means this citizen which is those who are having the symptoms related to a COVID-19. Okay, so these hospitals will provide the services. Okay, but how this will work? So this will work with means in these phases. So in this phase one, this is a data collection phase. So in this data collection phase, these automated vehicles, which is already assigned in some blocks, in every block. So these blocks, so in these blocks, these automated vehicles with the help of the IoT means some IoT sensors. They will collect the data, and this data will be transferred to this local RSU, and through this means after this local RSU, so means a vehicular delay tolerant nodes, means some vehicular nodes with which is a relay node, will transfer the packet from this means a local RSU to a main RSU. And after reaching this, so in the second phase, so in the phase I have calculated like this. So I have used some means FCFS because if some many people will come at the same time, so we will use this FCFS algorithm to scheduling algorithm to take data one by one. So after that, normally VVN collects the data means of the complete block and visit it. If some urgent conditions or suppose some problem occurred, then VVN immediately visit RLN to support means to transfer the data, and again it will get recharged and it will come again. So in the phase two, in the phase two, means the local vehicle will transfer the packet to the local RSU, and after that means in the phase two, means like VVN, when a VVN encounters with the RLN, so it will exchange the summary vector between VVN and RLN, and after that normally a calculation of the message index and the VVN transfer data to RLN, means finally the means in the phase two, the VVN will means the local vehicular node will transfer the packet to the means local RSU, and after that in the phase three, the data transfers from means RSU, that is the local RSU RL1 to this means relay node, and in the phase four, this means all this data means all these data are ready at the data center, that is the main RSU, and it is classified according to the patient's data, means their data collection. Data those are collected from them with the use of different sensors. So if the symptoms are related to COVID-19, then it will transfer the data to a COVID-19 hospital, and if it is related to a general hospital, then it will transfer the packet to the general hospital, and from there they will handle the situation, and they will send the help according to the disease to the people. Okay, so in the phase four, classification of data in the three categories, and after that a normal people can also be there, which these three categories are there. So this is the activity diagram of proposed work which I have explained till now, and this is how we are classifying the data. This is a healthy people 40%, normal people a normal illness people is 23%, by using a navy based classifiers. Here we are classifying this, and infected infected people 37%. So these are this is how I have solved the problem by with the use of a navy based classifier, machine learning techniques, and this Vehicular-Delay-Tolerant network. And after that, this future perspective of this Vehicular-Delay-Tolerant network. So automated vehicles means nowadays everyone wants automated vehicles, right? So till now the automation level is level 1 and level 2 in India, but after like Tata Ananya come, and some other vehicles are going to launch. Tata is also going to launch in 2025, and some other companies are also going to launch. So as 5G is also now going to start in India, as in IIT Madras 2 days back they have successfully implemented and trial. The trial was successfully implemented for 5G. So with the development of 5G communication networks and the Internet of Vehicles, as per the need of the automated vehicles, many vehicle applications such as route planning and video means like video compression and augmented reality navigation have become possible, and it will provide drivers with a more comfortable travel experience. Means like we want fully automated. So uh, these things means in advanced level vehicular delay tolerant network with internet of vehicles, means connected vehicles are going to provide all these facilities, means going to provide these facilities. And the next one is intelligent VDTN frameworks can enable mission critical applications to efficiently process interactive means entertainment content delivered with low latency and information transmitted with QoS awareness through edge intelligence. Because nowadays cloud is for low data, um, for low data we can means less data we can use cloud, but in the future when 5G and all the things are available, we can use means edge computing. So with edge means with edge VDTN can work for means in five means for a QS means in future. And next one is by using IOV, real time data processing is enabled to receive a data at a time. Okay, so these are the future perspectives, and these are some of my publications. As I mentioned, one of my publication, as I means explained. So this is means under review. Okay, thank you. If you have any questions related to my presentation, you can ask. Sir, Pallab sir.
Yes, sir. So if you have any question, any of the participant, if you have any question, then please go ahead.
Yeah, good evening, sir.
Good evening.
Yes, this was Sarah's question.
Yeah, sir, can you explain something about your dataset?
So, sir, actually, till now, I means I was using a manual data set only, but some real data sets I have collected with my students. So, means I am going to use that only. But for one simulator, we were using means only means existing data sets means based on the background networks.
That means particularly for the that means whenever we are transferring the data through IoT devices, so we are transferring the health data, I think so.
No, here in this work, I have used a manual data. Okay, so
Okay. Okay. Okay.
Okay. So any other question? Sir, I think I can ask one question here. So if no one is asking, so what I understood from your presentation, sir, is this vehicular delay tolerant network. It is the filling the gap of that vehicular network, which is basically the problem of frequent disconnection as the vehicles are moving with different speeds. So the nodes, they usually do not lie in close proximity all the time. Rather, they try to move away from each other. That's why the connection get lost between two vehicles, that means the two vehicular nodes. So frequent disconnection occur in case of a vehicular node. That is a traditional
yes,
thing that we know. So in that this DTN, it is using techniques like store and carry forward to successfully submit the packet and increase the network throughput. So this much we understood.
yes,
But in vehicular network, one very important thing is the vehicular traffic. So usually in vehicular network, we consider scenarios such as one is the highway scenario, the other is the urban road network scenario. Like in urban road, if you look at the number of vehicles present in a very specific area, it is quite huge as compared to the highway scenario. In highway scenario, the technique that you have mentioned there, that is the store carry forward network, carry forward technique, that is very prevalent to use, because in highway a less number of vehicles are present at any point of time in a specific geographical area. So definitely to relay the packets to the next relay node, it's not always possible to have so much vehicles around one particular sender vehicle. So but in urban node scenario or urban road network, I see, so there are so much vehicles are present in a specific geographical area. So is this VDTN has any technique to address the issues that is lying in this urban road scenario? in which the vehicular node density is quite high, because this store carry forward network, carry forward strategy, this is basically where the relay node is less number of relay node is available, right, sir?
Yes, 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 sir.
So is there any technique
So
in VDTN to handle the issues in vehicular network that is present in urban road scenario, in which a huge number of vehicular nodes are present in a specific geographical area?
okay. Okay, so at the means in urban scenario, what can happen actually means we can provide a best solution, like best choice problem means as means one of my paper I have solved this problem by selecting a best vehicular nodes in that. So if suppose means as per your question, suppose means to the source many options are available, means if I want to transfer a packet, so many vehicles are there to accept it, to transfer the packet from source to destination, right? So at that time we have to select, because means all are accepting, but means after some means at some point means if they will drop the packet, that the performance will decrease. So we can set a threshold, means like a best choice problem, and from means at that by this strategy, means by this heuristic algorithm, we can select only best of them. Okay, so
So
I
out of
think
many available choices, so we can select the best choice to forward the data packet. That is what you are saying.
yes,
Right?
yes, 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 sir.
Yes, sir. Thank you, sir. So,
Thank you, sir.
any other question? So, madam,
Sir, also,
there is,
sir,
yes, yes,
sir, can
yes,
I
sir.
ask one more, sir?
Yes, sure, sir, please.
Sir, just I want to know that, for example, the vehicles are moving in a multi-lane road network. Okay, so in
Okay,
that
sir.
case, the direction has some significance in the BTDN.
Yes, direction has some significance, sir, because suppose means in terms of infrastructure to vehicle transfer, it does not means have any significance. But
Yes, sir,
suppose
yes.
suppose when we want to transfer from vehicle to vehicle, sir, at that point it is having, because as I mentioned that means a source vehicle means have to estimate the speed and means all the dimensions, because it is going to transfer the packet. So means the
Whether
time
this is going to whether this is going to transfer the packet to the vehicle which is moving in the same direction or in the reverse direction also possible.
yeah, it's possible, sir. Means in the relative directions also, or in the means I mean to say in the opposite direction also, and in the same direction also. But means the vehicles have to calculate the relative speeds and all the dimensions, sir, because it is going to transfer the packet. And if it is not having a means estimated idea, so means it has to calculate it with the some means use of the sensors. Means one of my work is which I have presented in wireless network. It is already published, wireless network. So means I have solved this problem only, relative speed problem. So there I have considered our directions also, and means in the same direction I have omitted, but means I have considered that if in some point if the means another vehicle is going to change the direction, so means at that point what will happen? So at that time means that point means that vehicle is going to drop the packet, or means somehow means it has to transfer the packet to another vehicle which is available in the range.
Okay, sir. Thank you, sir.
So thank you.
So, Madhuri ma'am, so if no one has any other question, so can we conclude the session now, ma'am? Okay, so I hope madam is there. Okay, so let's we will now conclude the session. So before concluding the session, let me first present the vote of thanks. Firstly, I would like to thank Dr. Amit Kumar Singh for this lovely session on such a trending topic. Now, this is a very trending topic as this Internet of Things is quite in market. So, thank you for enlightening us with your research expertise. I would also like to thank Professor Dr. Devhuti Mishra ma'am, our head of the Department of Computer Science and Engineering Department. There's Dr. Sarada Prasanapati sir, Dr. Divya Sundar Das sir, Dr. Bharat Jyotiranjan Sahu sir, Dr. Madhuri Rao ma'am, for their valuable efforts towards making this webinar a successful one. Thanks to all the faculty members, research scholars, UG, PG students, those who have joined us during the seminar. Thank you all. So I think we should